Differential Calculus 2012, question 10b. A particle of mass m is fired horizontally through a block of resistive gel. The resistance to motion is m kV squared newtons, where v ms to the minus 1 is its speed. The particle enters the gel at a speed of 1000 meters per second, and 1/100 seconds later exits the gel at a speed of 10 meters per second. Show the k is 99/10. Okay, we'll do that first before reading the second part. So we have this particle here. We need to work out acceleration in this case. It's getting fired in this direction, which is my acceleration. There's a resistive force. We've been told it's m kV squared. M kV squared. So we're looking then at it's going in to the right, so it's going to be the force is equal to mass times acceleration. So minus m kV squared is equal to ma. So we can see that a is going to be equal to minus kV squared. And we know from our equation v is equal to u plus at. dv dt is equal to a, which enables me to find time. So that will enable me to find k. So let's have a look here. dv dt is equal to minus kV squared. So dv over v squared is equal to minus k dt. And if we integrate these, we'll be able to solve and find the value for k. So we're told, what are we told about velocity? Enters at a speed of 1000 and comes out with a speed of 10. Okay, starts at 1000 and finishes at 10. And my time, we're told, what are we told? 1/100 seconds later. So that's the last part. Enters at time is equal to 0, and 1/100, a lot of zeros in this question, later. So v squared is equal to v to the minus 2. So integrating it, we increase the power and divide by the new power, which is going to be minus 1/v. So minus 1/v, and that will actually, we can multiply across by a minus to get rid of the minus now. Between 10 and starting at 1000 is equal to minus kt between 1/100 and 0. So I can multiply across by minus 1. So we're going to get 1/10 minus 1/1000 is equal to, we're putting this in for t, so it's going to be equal to k/100. So we multiply by 1000, we're going to get 1000/10, which is 100. Not 1000/10, which is 100, minus 1000/1000, which is 1, is equal to k times 10, multiplying by 1000, so to be 1000 to be a 10 on top. So 99 is equal to 10k, so k is 99/10. Is that what we were asked to show? K is 99/10. Okay, in part 2, use the fact that the integral of dt over 9900t plus 1 is equal to 1/9900 by the natural log of 9900t plus 1 plus c, that's a c. Or otherwise, to show that the length of the block of gel is 10/99 by the natural log of 100. And that's in meters. Okay, let's start this part. So we're looking for distance here. Now let me just write out, we had velocity is equal to, we had acceleration is equal to minus kv squared minus 99/10, so 9.9 kv squared. K is 99/10, so minus 9.9 v squared was my acceleration. We know acceleration is dv dt, so let's just set up how we get back to distance here. My velocity is ds dt, isn't it? Let's just double check that. So we're trying to get back to s. S is equal to ut plus 1/2 at squared. So ds dt is equal to u plus at, which is my velocity. So my velocity is ds dt. So this is my A is equal to V times, just so we can get a ds in here. So to keep my dv on top, I have to have a dv, and I want to keep my dt on the bottom, so I need to get rid of the s. So you can see here, acceleration is v by dv ds. So we can set that up now. V dv ds is equal to minus 9.9 v squared. So I can actually divide across by v. dv ds is equal to minus 9.9 v. So I want the s on its own. So dv over v, and I'll leave the 9.9 on the other side, is equal to minus 9.9 ds. So if I integrate these, and my speed started at 1000 and finished at 10, and we're going to be looking for distance, so between s and 0 for my limits. So we're going to get the natural log of v. We know, we've seen this loads of times, 1 over v integrates to the natural log of v. Between 10 and 1000 is equal to s. You could put in the minus 0 if you want. Between, and it's minus between s and 0. I left out my 9.9 s minus 0. So that will leave us with the natural log of 10 minus the natural log of 1000 is equal to minus 9.9 s. So the natural log of 10 over 1000 is equal to minus 9.9 s. We're looking for s, aren't we? Let me just write down, we're asked to show that it's equal to 10 over 99. So you can see where these numbers are going to come from. 10 over 99 by the natural log of 100. That's what we're asked to show s is equal to. So I could, maybe actually from this line, I could change this around to the natural log of 1000 over 10, but if I just reverse this around and change the signs, I'm going to get the natural log of 1000 minus the natural log of 10 is equal to 9.9 s. So the natural log of 1000 divided by 10 is equal to 9.9 s. So the natural log of 100 is equal to 9.9 s. So s becomes the natural log of 100 divided by 9.9. We want to get a 99 on the bottom. So if I multiply top and bottom by 10, it's not going to change its value. Can you see that here? So I currently have s is equal to the natural log of 100 divided by 9.9. So I multiply top and bottom by 10. It's not changing the value of the right hand side, so I get s is equal to 10 times the natural log of 100 divided by 99, which is what they were looking for. So QED.